would have a human-machine interface, nothing happening, everything turned off. We have a engineering workstation, which is running OpenPLC, and we've got all the controls if we need to do an override or something here. So we'll go back to our human machine interface and control panel here. So we firstly need to turn on the power, then we need to adjust our feed. Now this is a very oversimplified demonstration. So what we want in our liquid propellants, in our rockets here, liquid propellants, there's a number of different things you can do, but 70% liquid oxygen to 30% RP1, which is kerosene. Once we've adjusted that, we'll run our compressors up. We can turn on our compressors, our feed. So here we go. We're going to turn our feeds on, and we've got, and you can see here, if I just turn them off again and off again at the human machine interface, you can see here. So we've got our feed going through, and we're prop loading our rocket. Now, what happens at this point in the car park, 5 kilometers at a safe distance, we have the crowd go absolutely nuts because they know it's now T-40 because there's mist coming out of the prop load from the condensation. So the people in the car park cheer wildly, start grabbing for their cameras because they know it's only 40 minutes out. Now what happens here, so everything's normal, you know, we get our prop. Now the thing is if there's a mission abort, all the propellant has to come back out from here, back into the tank, because you don't leave it on the rocket. Pack the Modbus, they're on the IP address, they're looking at port 502, they've got access to 502 on our PLC. This is our PLC. This is Open PLC and our plant logical controller. The hacker comes in, goes, how can we mess them up? Should we turn off the liquid, the kerosene or the liquid oxygen? So what they can do is, what would be the most damaging? If the kero turns off, they could probably recover that because it's a 70-30 ratio. If you turn off the liquid oxygen, that could create a bit more of a headache. So that's what we'll do. We'll go here, or these relays are upside down at the moment, but just don't worry about that. So we change that 0 to a 1. You see that's changed to a 1. The RP is still on 0. And oh my God, we've lost our liquid oxygen feed to the rocket. Terrible. So what are you going to do? So the engineering team gets in, they isolate the attacker, and they go, okay, let's turn our liquid oxygen back on. And we're back and working. So we didn't necessarily have to do a mission abort. A mission abort can be costly. So here we are at Adelaide BSides, SpOT the ICS. This is part of experiences and things that we want to create, where I coach and do some education work, and that is a demo.
Either operate or go to the monitor. So PLC does have a program which is written to control some process, and that is a real PLC. Now, this why we have created is for people who are coming from non-automation background, which we learn because this to get an access to the environment. I don't think so anybody is going to give an access to anyone. Situation there where the logs are not going from here to the steam platform. Situations are good, but it's getting bad. Engineer is monitoring HMI and he's saying that, something is abnormal, this is not normal. The same SpOT analysts are saying that, there's no incident, everything is all good. Yeah. Why? Because there are no logs are going on in there. They are trying to do the debate, there's no investigation, and during the time, something happens and it is out of control.
The smoke.
It's bomb, it's a blast.
I wasn't the same, so it doesn't matter.
So the
G'day and welcome. We're at the SpOT, the ICS Village at Adelaide BSides. SpOT the ICS, yes, the space, OT and industrial control system. So we have a rocket that's ready to launch here. We've got prop load going on. We've got the people in the car park 5 kilometres away. Oh, we've reached T-minus 40 because we can see the prop load is starting. The news is going up. And we can see on our human machine interface is here behind. This is our industrial engineering workstation. We can change the values here, and when it's finished we can turn it off. So what we go to then, there's not much point having an engineering workstation if you don't have a human machine interface. We can see what's going on, everything 30% RP1, 70% liquid oxygen going through to our prop load. So that is how we launch. We get into space at T-0. Now we have, space has 4 segments. It has the space segment. It has the link segment from here to here, and it has the ground and user segment, which are the people on the ground who might also operate one of those, but they also operate these. They need to talk to, via the link segment, the payload in space. So, in space is critical. It is congested and it is contested. Some of these satellites can get a bit frisky and sneak up and jam each other and do these kind of things. And if you draw your attention up to here, you can see this out of control satellite is a bit wobbly, and the ground control or mission controllers are having a little bit of trouble talking to it. And of course we can use our Yagi antennas. Here we have the link segment that we talked about. We have TM, telemetry monitoring. The downlink, we have TC, the uplink. When you talk to a bus to get information on your sensors, you need to address the bus with your APID, which is like a command that you send. And commands like ping is APID 1. In this case, you can program them to whatever you want, depending on your mission design, your payload. And what you find is, not unlike TCP, you have a packet type, APID command, a sequence, a length, a payload, and then your flags and the sequence to. So one of the attack vectors can be recording the downlink, spoofing the APID by doing a replay attack by taking the sequence and changing the data and sending it back. And if you have taken control of the mission payload because you got into proximity, you jammed, and you got the downlink to associate to a different channel because your RF frequency overpowered it, there are some really bad things that can happen. So that's why space is critical. That's why we're here at Adelaide BSides having a great time with Sanam. And that's a little summary.
Hi Peter, how was the village?
It was an experience because we've got everything going on here. We've got it all happening, and experiences and exercises are what it's all about.
Yes.